Hello, Common Core Algebra 2. So today we're going to move on to our third way to solve a system of equations. We're going to do it by elimination, and this is Chapter 3, Section 3. So we've talked about graphing, substitution. Today we're going to do elimination, and the next method is going to be matrices, which will mostly be done with your calculator. Okay, so to solve a system of eliminations, we're going to have 4 steps. The first one, we're going to multiply one or sometimes both equations by a number that will create opposite coefficients for one variable. So the biggest piece there is we have opposite coefficients, and we only need it for one variable. Sometimes it could happen for both, but the most important piece is that it happens for one variable. And then after we do that, because they have opposite coefficients, we're going to add those two equations. This should eliminate a variable. And in fact, it should eliminate that one variable that had opposite coefficients. If it does not, for some reason, eliminate one variable, you made a mistake in step 1, and you need to go back and try to fix that. And since there is only one remaining variable, you're just going to solve that equation, that one equation, to figure out what that variable is. And then we go back to, like we did for substitution, and we're going to substitute into any of the equations that were created, either the original equation, either one of the original equations, or one that we created after step 1, and we're going to solve again. So big thing here, we're going to multiply one or both, we're going to add the resulting equations, we're going to solve for the variable, we're going to take that value that we get in step 3, we're going to substitute it into any of the original equations, and finally solve again for that remaining variable. So what does it mean to have opposite coefficients? Well, the biggest thing here, opposite coefficients means that for one variable, you're going to have the same number in front of it, that's the coefficient piece, where one is positive, one is negative. An example like here, if we say, and again we can do this for any variable we want, doesn't matter which variable you choose, I'm just saying let's do that for x in this example. So I've got 6x here and 2x here, I want them to be opposites, and I want them to be the same number. Now there's several different ways you could do this. An easy one to do here, we can just multiply this second one by 3, but a surefire way is to take whatever the coefficient is of the other equation and multiply that equation by that number. So what do I mean by that? We can take this first equation and multiply it by the coefficient of the second equation. So I'm going to multiply that by 2. And when I multiply this first equation by 2, I have to do each piece. So it's like distribution, which means 6x times 2, negative 2y times 2, and also the 1 times 2, which would give me 12x minus 4y equals 2. Okay, now the second equation I'm going to take and multiply by the opposite coefficient of the first, because they're not opposite signs yet. So I'm not going to just multiply by the 6 because that wouldn't give me the opposite numbers. I need to multiply this by negative 6. If they were already opposite signs, you could just multiply it by the same coefficient. So again, each one. So 2x times negative 6, 3y times negative 6, and negative 5 times negative 6, which gives me negative 12x plus a negative 18y equals a positive 30 now. So that's step 1, and you'll notice now here these are opposite coefficients, 12x and negative 12x. So that when we do step 2, those should cancel out, and we'll be left with just an equation for y. Okay, we'll look at what that looks like in another example. Now again, I multiplied the last ones to get those values. What I'm going to do here is just show you the opposite way. This one I'm going to solve, I'm going to multiply for y first, which means I need to take this first equation, and since I'm doing y, you'll notice that the values are already opposite. I'm going to multiply this one times 3, which gives me an 18x minus 6y equals 3. And on the second one, I don't want to multiply by negative 2, I'm going to multiply by a positive 2. So always the opposite of that first one. So 2 times 2x is going to give us 4x. 3y times 2y is going to give us a plus 6y, and negative 5 times 2 is going to give us a negative 10. Okay, so we could have solved the other one as we saw it just now, adding the two equations and solve for x first. Here I'm going to solve for y first just because I wanted to show you it doesn't matter which one you do. You'll notice your y's have opposite coefficients, so when we add them, those should cancel out completely. 18x plus 4x is going to give us 22x, and that is going to equal 3 plus a negative 10, a negative 7. Okay, in solving this for x now, we divide both sides by 22. We're going to get a decimal here. That's okay. Negative 7 divided by 22, if I do that, in my calculator, I'm going to get negative 0.3, and I'm going to round that off to negative 0.32. Okay, that is step 1. So first, and step 2. So step 1 was right here multiplying. Step 2 was solve. Step 3, I'm going to come over here, and again, it doesn't matter which equation we choose. I'm just going to take that first equation because that's always usually easiest for me. Just take that first one, no confusion, and I'm going to plug in negative 0.32 for x. So 6 times a negative 0.32 minus 2y equals 1. Okay, and if I multiply that 6 times negative 0.32, I get negative 1.92 minus 2y equals 1. Okay, add that negative 1.92 to both sides. I'm going to have negative 2y equals 2.92, and then I'm going to divide that by negative 2, and so y will equal negative 1.46. Okay, so we'll round both those off. So that means my solution is negative 0.32 and negative 1.46. Okay, which if we then plug those two values back in, that would give me a true statement on each. We may be a little bit off because we rounded off those numbers, but that's okay. As long as they're close, it tells you that your statement is true. All right, and that is it. So major steps, you're going to multiply one or both equations by some number so that we create opposite coefficients. That's a big piece, opposite coefficients there. You add the two equations together then so that your opposite coefficients cancel out. And then you're going to solve the resulting equation for the only variable that should be there. And then we do just like substitution. We take that value, plug it back into any of the original equations, and solve it for the remaining variable. That leaves us with an x and a y value, which means we have a point of intersection just like we saw with our graphing. Okay, see you next time, guys.